for coming. So this is named kind of evolving the fetching and networking on the web platform. So as I talked about in the keynote, so we've been kind of trying to evolve the fetching and networking concept, starting from XHR and the WebSocket for bidirectional communication and so on. And recently we are shipping the web streams for more efficient with processing and transformation. So I'd like to get a feedback on what next to kind of for this area, what we should prioritize. So this session is basically brainstorming, but I prepared a few slides, only 3 slides, including this slide. So currently we are working on the streams and BlinkOn related work, and also exploring some opportunities listed here. So starting from, we are kind of receiving some requests to enable compression for upload direction that is currently not available, or so given the kind of we are moving more for giving a more powerful web platform, kind of one missing thing for gaming apps is kind of UDP-like, unreliable interface to communicate with the cloud, and so on. So there are a bunch of stuff we are thinking about. I'd like to hear what you all and the developers are interested in and what we should focus on. So yeah, I prepared a few slides. I listed in the talk description. So first one is upload compression, and the second one is kind of UDP for the web stuff. So this is just a summary of what we've been discussing. So let me just quickly go through this, and even anything other than this could be discussed here. So, but let's upload compression. So yeah, as I said, so some people, developers are asking for upload direction compression as, for example, RTC with RTCs for web. Upload direction is currently basically not compressed, and some people are just using the JS, or we could now use WebAssembly for faster processing, but they're kind of using this kind of same kind of profile for this purpose. But we could do some improvement for this by providing some embedded compression interfaces, such as one possible option is just doing this kind of stuff at the HTTP level, so nothing is exposed to the web API. Or we could just for more safety or for more compatibility or like that, so we could add some option to the fetch API so that we can explicitly opt in. Or other than this, we could use the streams stuff to introduce kind of compression transform. Using that, we can just combine all the fetch API and this compression API so that manually but efficiently introduce compression features to the web like that. So that is something else for this kind of input before. And also the other topic I prepared is unreliable communication. This unreliable may indicate a virus stuff, just reducing the transmission and ordering, or getting rid of congestion so that the application could get more control over that. So there are pros and cons and objection and request. A lot of stuff has been kind of happening between us and some game developers or remote desktop developers or like that. So, but one of the big problem is the security in order to realize this kind of stuff. So there's a bunch of things to solve, but and also
missing from data channels?
WebRTC. Yeah, it's kind of recent feedback we are receiving that it's currently kind of too complicated peer-to-peer forecast. So I haven't get into the detail, but we've been having some discussions. So Adam, could you talk about kind of recent status?
Okay, so we've had some discussion about WebRTC data channels, and so what we've heard from web developers is that they find it too complex to deploy, and that seems to be the main objection.
But it's unreliable. It's usually like in all the workplaces.
Yeah, well, this feature could be provided.
So part of the intent of WebRTC was to have the low-level building blocks, and then you can build libraries on top of it. So are we just missing a library on top of WebRTC for this, or
Is it the server-side deployment or the?
My understanding is the server-side deployment, because it's a peer-to-peer protocol. People seem to find it difficult to fit in to their browser to server architectures, and there are just a lot of moving parts.
Yeah, we could just build them on top of it, but yeah, that might be. Yeah.
So one idea we discussed was whether there could be some kind of server in a box type deployment solution that would simply solve the deployment problem for people, and then that might actually make it attractive to deploy.
yeah, like a proxy that turns UDP traffic into datagrams? Is that what you're thinking?
So yeah, one thing that often happens with WebSocket is that people have a sort of proxy that wraps their legacy TCP/IP protocol in the WebSocket.
Yeah.
So if you could do a similar thing with a UDP protocol, then I think that would be easy for people to deploy.
That makes a lot of sense.
Yeah. So does that cover the WebRTC question? Because we actually have been looking at this over.
Is handshake congestion control yes, no, like that? Is that
So
okay with data channel, or does that need discussion?
okay, so WebRTC data channel apparently does have congestion control. This is an important feature, at least from the point of view of an unprivileged API, because without congestion control, they can basically just kill the weakest link you're connected to, which might be your ADSL or it might be your ISP. They can flood any link, basically, which is not good. So as an unprivileged protocol, congestion control, as far as I can tell, is compulsory. There is somebody who's not on Blink or Google has developed a sort of proposed API with an implementation as a browser extension, which does pretty much what we need, except I haven't looked in detail at the security solution, and doesn't have congestion control. And so what I've heard, so we had a discussion with Peter Thatcher, who works on WebRTC, and he felt that congestion control was very critical, basically. And I've concluded the same thing, that if we want to provide an API that, like WebSocket, doesn't require some kind of user interaction, that the page can just use it, then it has to have congestion control, because as far as I know, there's no other way to prevent the Obviously, you could have something like, well, we're going to limit it to 10 packets per second or something. That's not going to work for somebody's use case. If you're going to have limitations on it, let's have a limitation based on rational, a well-considered idea of what the environment can actually support. That's what congestion control does.
So when I've heard of UDP for the web, I've basically heard two use cases. One is what you're saying here, games need something unreliable and out of order. And that just sounds like data channels to me. And I've also heard that another one, we want UDP to replace Chrome apps so we can do interface with legacy applications. And that's a completely separate use case.
So we haven't been looking very much at that second use case that's been kind of described as native sockets.
Yeah.
So it would probably be not just raw UDP, but also raw TCP/IP.
Yep.
And that would handle many use cases that you can currently only do in Chrome apps.
Or on the web using a server. Like, I find it frustrating when people are like, oh, the web doesn't have this capability. But what you're saying is JavaScript doesn't have this capability. Like, if you have a server involved, easily talk to UDP apps, like UDP.
Yeah, I mean, I think, and from a security point of view, just being able to wrap UDP in some protocol that provides the security properties that we need is far more attractive. This idea of native sockets requires a very formidable user barrier. Basically, we're trying to exclude non-technical users who don't understand what the property is. The idea is that the user has to type the host name that they want to connect to into a dialog box to indicate some degree of familiarity with what they're attempting to do. But I can see even there are problems with social engineering.
I would say for the purposes of this, that second use case isn't really a thing we're even talking about, right?
So we've been mostly looking at the first use case, that can drive by on a non-permissioned use case, the highly permissioned native sockets use case we haven't really looked at in detail. So I know Justin Shu on the security team was working out a security model for that, but I don't know if anyone's actively working on it now.
I mean, just in terms of prioritization, it's like important to kind of weigh both. If it turns out that 90% of our users only care about the second use case, then like, okay, maybe we shouldn't spend time on the server in a box for the first use case.
My intuition is it's the latter, like 95% or 99% is this use case that we're done.
So what? Yeah, I mean, we hear some. So I'm not going to go into details, but for the desktop sharing type applications, this kind of unreliable protocol is very good. But I hear that's actually quite where WebRTC is quite strong already. So maybe that's just a matter of, again, if there was a server in a box or something that made that easier to deploy, then that might just solve that problem. But the other thing we hear a lot is games. Apparently there are a few web games like Agar.io uses WebSockets. They do okay, but most game developers are like, no, this is a non-starter. We have to have something that's UDP-like. So that's basically what we hear. So yeah, the way I view the separation of the two, so this web UDP thing or WebRTC data channels or whatever we're calling it is mostly targeted games and maybe a few other niches, but it's about the game is the overwhelming demand area we hear. The native socket is targeted at things which are currently Chrome apps. And SSH is one thing we hear a lot, although some of the conversation there seems to be going along the lines, well, we'll do the connection setup in the browser, in which case, why not just implement the whole protocol in the browser? So there's a fairly clear separation of use cases there. So we were discussing, well, maybe if native sockets goes ahead, then we won't look at this side anymore. But there's a fairly clear separation of use cases. And certainly, as Dominic was saying, if you have an existing UDP protocol and a proxy which you can wrap that, then you can solve a lot of your problems without needing to have the full power and danger of native sockets on the web. So that's how I view the use cases. And I forgot what we were talking about before.
Sorry, interrupt.
Do you want to, it's interesting other topics, so we could continue this, but for compression or any ideas?
I've been saying, like, before I joined Google, that like it's a shame we have all this compression code in the browser, and that if you want to compress something on the web page, you have to rewrite it, compile it to JavaScript. I really think we should expose it. Extremes is the best API. I think the first two options are just variants of the current situation where we're locking it up inside some other functionality.
Yes, I agree.
Actually, the last option best fit the extensible web manifest and all the So we are just kind of going to go to further or thinking about this experimenting from the easier and opt-in method, but the future should be
Yes. So the more attractive API for me is a streams-based API. Basically, you have a byte-to-byte transform which does your compression for you, and upload streaming will be in fetch real soon now. And at that point, you'll just be able to pipe directly to your upload. It will all be beautiful and work, won't waste any memory. There's been discussion as to the kind of short-term thing of having just a simple functional API. You give it a chunk of data, it gives you back the same chunk compressed. It's less flexible, and my major concern is that if we're going to standardize something, it's going to take a year anyway. So why not standardize something good?
You could try and do it expensively, like, I don't know, what do we call this thing? Compressor. So we have a new global called compressor, and it has a static method called compress, and that takes a block or takes a bytes and gets some bytes.
Just kind of takes the encoder and decoder.
Yeah, exactly. And then we, in the future, we make that compressor object a constructor for a transform stream. I could see it incremental path. I am curious if there is a short-term need. Like, I'd love to hear more about why. I hadn't really heard about. I felt like I was alone in saying, let's get this to web developers, and now you're saying there's like a short-term need. We need to get this out now. So,
from analytics providers, I know that we recently purchased Sosta, and they're doing a lot of crazy things. They're downloading a lot of JavaScript in order to compress resource timing, user timing, in order to upload that and make sure that it doesn't upload more than a single TCP window. And there's a lot more data that we would love to upload if we could afford it from a user bandwidth perspective. So compression API would definitely enable that. I think I started gathering use cases on the WSCG thread. One of the use cases, the more exotic ones were to implement SSH and Git in the browser. You need a way to use it. I can look it up. But our most pressing, like for us, the most pressing use case is that being able to upload more data from the browser for analytics purposes.
So the way I understand the history of this, which may be wrong, this is all secondhand, is that there's been discussion for a while about having an HTTP level way to do a gzip upload. It seems like a natural capability, but apparently there are major sticking points with middle boxes, just throwing away the relevant headers, messing everything up. So that's why the focus has kind of moved now towards a JavaScript API, which seems more generally useful anyway. I mean, solving it for HTTP solves it for, I don't know, 9%, 8%, but solving it for in JavaScript seems far more impactful. I mean, so for something like form uploads, you can make an argument that like an old-fashioned form upload with no JavaScript could benefit from a built-in HTTP feature, but couldn't benefit from a JavaScript feature. But on the other hand, how much compressible data do people really upload via old-fashioned HTML forms? I don't know. I'm guessing not all that much.
I know that people it's a slight tangent, but people are using Canvas in order to compress images before uploading them. So
But what does compress images mean?
So basically convert the bitmaps or whatnot into JPEGs or convert JPEGs to a lower quality before uploading that. I've seen people do that.
That's possibly not that terrible, actually.
Yeah, that makes great sense.
That's actually, I consider that like fairly sane. I mean, it's if your aim is just to have a standard image format, then yeah, that'll work.
Canvas is a weird API because it just grows all these capabilities. It's like originally like, yes, this is for displaying stuff on the screen, but then you're like, no, it's also our intermediate transform API for like image formats and everything else. So I understand that it being weird from that perspective, but given that Canvas is already that way, it seems okay.
Yeah.
So I'm a bit confused. Like your use case seems to be like this is I don't know how to say this. Like, you break some data when you compress image, right? Like, the image quality is not the same before and after compression.
Yes. So
lossy compression.
yeah, the image is not my use case. I've just seen people do that, but it's for images that are uploaded by users. If you don't want to rely on the fact that the user has properly compressed the image in terms of compression settings, in terms of image size, you can do that on the client and then upload less. That's what I've seen people do.
So should this like compression API also?
So I don't want this to also solve that other problem, but it's slightly related because I don't want this to be.
I think this is sort of similar to a general question that's come up a couple times about capabilities the browser has and whether or not we should be exposing them to JavaScript. Things like the browser has an implementation of gzip. Should we just make that available? Like we have a JSON parser and we do make that available. We now through Canvas we have various image compression, decompression libraries, and we make those available to script. It's like, should we decide to make these algorithms just generally, like we have to have them to improve web properly, and so should we make them available so that people can do various things with them, or should we force them to report them in JavaScript or WebAssembly?
Yeah, I think gzip is an obvious case where the answer is yes, we should make it available. I can see absolutely no drawbacks apart from the time taken to standardize and implement it. But For other things, I mean, if people want to like do streaming creation of JPEGs, then doing it by Canvas is not going to work because it's going to want to bring everything into memory. But that seems like a pretty minor use case to me. And you can always like split your JPEGs into chunks the old-fashioned way.
There are people who are trying to do similar things for video compression formats. And I hear secondhand that it's very difficult to do manipulation of video using our existing interfaces.
Yeah, so actually I've been having some discussion about connecting streams to the media streams. So we have two different things called streams, which is fun. We have media streams, which do media things. Then we have streams, which is general capacity to do, general capability to do streams on the web. And the idea is we're going to bridge those two things and make it much easier to like have your own video codec running in the web browser. Now, probably unlikely that we'd expose video codecs as part of the platform. But, well,
No, I mean, like, let's say you want to record frames, send them through, like, get them from the Jet User Media, send them through a canvas and put funny hats on them, and then compress it into MP4 to upload to your service.
So that's already kind of supported through WebRTC media streams.
The last step, the compressed
Well,
MP4 is what I was unsure about.
Creating an MP4,
Okay.
no, but creating an MP4 stream, yes.
Okay. Yeah.
You can do the put funny hats thing like in the middle of a WebRTC session.
Can you?
Yeah,
but
no,
can you,
I'm just like the upload step, I'm not sure about. I just don't have enough WebRTC familiarity.
Yeah, you could send that over a WebRTC peer connection, but I'm not sure if you can stream that into a fetch upload.
No, you can't. On the server though, you can then create a file. If you're
Right, but then you need to do the WebRTC on the server, and that's apparently very difficult.
we have a lot of capabilities which are kind of partially exposed to the web. One, it's kind of an aside, but one crazy one I heard of recently was people synthesizing downloads in a service worker. So in a service worker, you can just create a fetch with the necessary headers to say, hey, this is a download, and you can stream data into it. And so if you actually want to create like a PDF on the client and have it saved in the download folder, that's basically your only game in town as that I'm aware of.
You can also create a blog and create a blog URL, which is sort of the same thing.
Can you send that to the user's download folder then?
Yes, that's what I think the Mega Upload download client does something like that. It streams, it downloads all the chunks and streams them into IndexedDB and generates a blob and then downloads the blob. It's awful because it uses twice as much storage as the file actually takes because it has to store the blob inside of on disk blob storage and then download it.
Why are they doing that?
Because they have a download client. They want to implement more reliable downloads of large files, and so telling the browser to just download 7 gigabytes of data is unreliable.
Right.
It is slightly more reliable to do chunked downloads, possibly from multiple servers, into local storage, and then trigger a download of that content so you actually get the file on your file system.
Interesting. So this is a capability we're partially exposing in two different ways. How to put something in the user's download folder from the client.
It mostly works except for this odd pause. Like after the download's finished, there's just pause as it like downloads it from itself again.
So yeah, I think where we've got a capability that's kind of partially there, we should think about filling that in a kind of rational way, so it's all the way there, rather than forcing people to go through strange avenues to get it to work. It's like the UTF-8 encoding on the web used to involve using URL encoding, was it? Is that correct?
I think, yeah, saying that.
Because the browser could do it. There was no official API, so just send it into a URL and encode it that way, and you get your UTF-8 bytes out. I think you had to like decode the hex, if I remember correctly, in JavaScript. which is fun.
And now text encoder, decoder.
So now, yeah, text encoder will do that for you, and next thing is streamed text encoding, which I am working on.
So I'm curious about JS and WebAssembly-based compression for implementing alternative compression stream formats without actually speccing them into HTTP, just because it sounds like an interesting idea.
Yeah, I think that should work. So if your application is large enough that you can have afford that extra weight in it, then by all means. But given that we already have a gzip implementation in the browser, which is simply not exposed, I think it's reasonable to expose it. So one of the things I wanted to talk about was
That's to follow up on that. Like the idea behind if you ground this all in streams and transform streams in particular, like there will be a built-in transform stream where you say like new decompressor, maybe pass it some parameters, and you pipe through that, and you get out the new compressed version. But then you can also just like get one from a library, like that somebody else writes, and it'll be the exact same API, just for new super compressor.
yes,
I'm excited.
that's the magic of
I
streams.
don't know if you have more you were wanting to say out there.
There's
Riley.
composability.
I was just thinking about it in terms of how it would integrate with the existing Fetch API and just the general resource loading path. Like, could you set it up so that let's say we had a new compression out of like Pigeon or something? Could you actually get all of the resource loads for your origin to use that, or would you have to have some wrapper that your site internally used every single time it loaded something?
Serviceworker.
Yeah, so
You
I was
add
thinking
an
Serviceworker would
encoding,
probably, yeah. Yeah, I was imagining like a service worker
which
that
will
would
mean
check
that
it.
cores will get, like, can you add a new accept encoding parameter?
I think you have to cheat and give it a different name.
Yeah,
call it
so it's
my
not accept
accept
encoding
encoding.
and then cores will be mad at you, but
Cores will be mad at you, but
you don't
if
want
it's same
compressed.
origin, you're okay.
Yeah, you probably don't want to compress it before sending it to some other origin. Well, maybe
Yeah.
you do, but
yeah, then you have to get those resources back and pipe them through this magic decompressor thing.
I mean, it should be like a 3-line service worker.
Yeah.
Yeah, so that's kind of doable already. It's kind of ugly. We're going to be shipping transform stream real soon now, which will make that less ugly. You still obviously have to implement Pigeon, but that's left as an exercise for the developer.
Okay. Thank you so much for your input and comments.
Thank you.
Yeah, thank you.